Yes, ma'am.
Okay. So today we are going to start chapter 1, and that is going to be an introduction. So for our subject MIT 11053, Fundamentals of Programming. So this is a kind request. Can you please all of you mute? If anything to clarify from me, you can ask. Otherwise, please mute yourself. Okay. So as you are aware, this subject is supposed to be taught by myself and Professor Sabras Navaskar. So sir also will be doing his part and it's me. So normally like sir is the one who starts the things, but unfortunately this time like he wanted to start me. I mean he wanted me to do chapter 1 for you all. So I will make sure that I do it as simple as possible because this is of course programming and yeah, so things are going to be very new to you, like unlike other things. Okay, but nothing to worry. So of course this will be very and this will be really interesting. So in my case, this is the most favorite subject among the subjects I teach to the students. For me, I find it really interesting because it's really interactive and it's not like just the notes or what we call just the theory things. So here we have so many practicals, we will be dealing with so many programs. So this will be, of course, really interesting. So just get started. We have this chapter 1. Okay, so in your idea, or based on your idea, based on what you know, based on what you think, I know students from here in this group, so some of them have already studied ICT for their A levels. Okay, so based on like whatever you know, just tell me what do you mean by program? So your idea, tell me what do you mean by program? You have to discuss with me. Tell me what do you mean by program? So there is an answer in the chat, a set of instructions given to the computer. Okay, good. Other than that, what do you think the program can be? Number of collection of processes. Okay. Any other? Okay, all right. So good answers. Okay. So here, computer programs, which we are calling as software. Okay, so during your orientation program, while you were introducing yourself to me, so like most of the students were telling that you want to become software engineers at the end of the degree. Okay, so what do you think software engineers will be doing? Tell me what the software engineers will be doing. You all told me that you want to become, like most of you told me you want to become software engineer. So what do you think the software engineer will be doing? What's his or her role? What those people are doing actually? So there are answers. So one is coding or programming. Okay, good, of course. Develop software, making software, writing programs, create programs, or create software, developing software, programming. Okay, good. So here, what these people are going to do, of course, they are going to deal with some programming. They are going to write programs. They are going to create programs, which we are calling as coding. So people are going to do some coding in order to come up with a software, or which in industry settings we call as a product. Okay, so this is the fundamental. So this is where you are going to learn, you are going to start with the very basic. Okay, so here just to start, what is that? Computer programs, also known as software, are instructions given to the computer. Okay, you are asking the computer to do some, so you are in some way. Okay, so by in some way, so we will study, we will see what that way is. We are asking the program, sorry, we are asking or we are giving some instructions to the computer to perform some tasks for us. So that's what we are calling as computer program. You tell a computer what to do through the program. Without programs, a computer is an empty machine. Computers do not understand human languages. So you need to use them. You need to use computer languages to communicate with them. Okay, so now we are coming some bit closer. Okay, so you tell a computer what to do through the programs. Of course, you all should be agreeing with that. So that is the set of instructions we are giving to the computer. That's the set of instructions we are giving to the computers. So here, one thing. So giving these set of instructions, okay, so we human, okay, so now if we take this scenario as an example, now I'm teaching, I'm explaining some content to you all. So we are human, we are all human. Okay, so here I'm using a human language and you are able to understand it. So don't you think if I talk like this, if I talk like this to my PC, to my laptop, do you think that it can understand any idea or like what is the mechanism used there? Whatever the idea you have, you can tell me. So do you think like the way that I am talking to you, since we are human, you can understand what I am talking. Even if you are telling me something, I'll be able to understand. But the same thing, in the same manner that I am talking, do you think a machine can understand, or what we are calling as a PC, a computer? Can it, can it understand, or are there any other things? Are there any other mechanisms that we should use to make them understand? Very good. So no, it's a digital machine. So it can't understand the like whatever we are talking. So we as a human, whatever we are talking, the machine can't understand. Okay. So especially what we are calling as human languages. Okay. So maybe if I tell computer something in Sinhala, it won't understand. Something in English, it won't understand. These are what we are calling as human languages. So these, the machine, the computer is not going to understand. So what we have to do, so you need to use computer languages to communicate with them. Okay? So those computer languages are what we are calling as programming languages. So there are variety of programming languages. There are variety of programming languages. So tell me some of the programming languages you know, and also tell me what is the programming language we are going to, like if you have any idea, maybe you would have talked to your seniors or previous students, pass out people. So tell me what is the programming language we are going to learn in this subject. So I'm asking two questions. I'm asking the programming languages you know and what we are going to learn here. Okay, very good. So there are like lot of parts. Okay, so you are telling so many programming languages like C, C++, Python, and you are telling that we are going to study Java here. Of course, very good. Okay, so that's yeah. I'll move to the next slide. Programming languages. Okay, so programming languages can be categorized or like what we call the forms can be like mainly they are categorized into three forms as machine languages or machine language, assembly language, and high level language. Okay, so machine language is a set of primitive instructions built into every computer. So machine language in the sense what we are calling as ones and zeros. Of course, like whatever the instructions, whatever the things that you are giving to your computer, at some point it will be converted into ones and zeros. The machine can understand only these ones and zeros. Okay, whatever the instructions that you are giving, those will be understood by the machine only in the form, if it is in the form of ones and zeros. So that is what we are calling as the machine language. So machine language is a set of primitive instructions built into every computer. The instructions are in the form of binary code. That's what we are calling as binary code. Ones and zeros, we are calling as binary code. So you have to enter binary code for various instructions. Programming with native machine languages. Machine language is a tedious process. Moreover, the programs are highly difficult to read and modify. For example, to add two numbers, you might write an instruction in binary like this. Okay, so here, like now, we are actually looking into how programming languages from the beginning, how they have evolved. So the initial part was about having the machine language. So machine language in the sense it's only the binary form or binary code. So binary in the sense it's only ones and zeros. So what happens here? Whatever that you are trying to, whatever you are trying to give as an instruction in the form of a program, that whatever the thing you have to convert them or you have to enter them in the form of a binary code, which is very difficult. Okay, so that is the idea you have to keep in mind about the machine language. And then the assembly language. Then after we are having assembly language. So here in the assembly language, what happens? As assembly languages were developed to make programming easy. Okay, so here one thing you have to keep in mind: machine languages are more tedious. They are more difficult. Okay, so whatever the instructions you are having, you are supposed to give the computer whatever the program that you wish to write. You have to convert them everything into ones and zeros. That's difficult. Okay, so here the next part, the next stage, what is that? It is about having the assembly language. So assembly languages were developed to make programming easy. Since the computer cannot understand assembly language, however, a program called assembler is used to convert assembly language program, programs into machine language. For example, to add two numbers, you might write an instruction in assembly code like this. So here what happens, there comes an intermediate. There comes an intermediate called assembler. Okay, there comes an intermediate called assembler. So here what happens, you don't have to actually convert everything into a machine language. Here you can write the thing and the assembler will be doing the task of converting the assembly language into machine language. That happens. Even that again is a tedious, that again is a problematic task. So now we will move to the high level language. The high-level languages are English-like and easy to learn and program. For example, the following is a high-level language that computes the area of a circle with radius 5. Okay, so now these are even this Java, whatever we are calling Python, C, C++. So these are the forms of high-level languages that we are using because they are more like English. So here you have to know the syntax, the sentences that we will be writing in the program, everything they are more like English. Okay, so they are considered as English-like programs, English-like languages. So that's the part of high-level languages. So these are the three forms on which on the basis of which programming languages have evolved. Initially, it was machine language, and then assembly language, and then high level language. Is that clear? Is that clear? Are these clear and understood? Okay. So now I will move to the next part. So here you can see some of the popular high level languages. Okay, so maybe this COBOL, Fortran, Basic, Pascal, Ada. So these may be sometimes not familiar to you, but we like this C, Visual Basic, C++, Java, C Sharp. Okay, so these might be sometimes familiar to you. And for our subject, yes, you all yes, as you all told me, we are going to learn about. We are going to learn Java. So the programming language that we will be using is Java. So these are some of the examples for popular high-level language. You can see. Okay. So now we have to think about this one, this part. How actually a computer program works. How actually a computer program works. So any idea? So even I'm showing the slide. So just you tell me. So like, how do you think? Or what's your understanding on like how a computer program can work? For example, now you are going to write a program in Java. And once you are executing it, it will give you the output, which means the computer has understood the program and it is giving you the result. So tell me, like how that can happen? Like, can you discuss with me? So someone is telling that you can't unmute, of course. So since day one, I have been telling you, please keep yourself muted unless it is wanted. But it doesn't work, so I have muted everyone. So maybe you can use the chat and just discuss with me. You can go through the slide and you can tell me. So there are many answers. Very good. So one answer I will read. Compiler has changed our program code into machine language. Then counts the output. Okay, very good. Something like that, no? When we are writing a Java code to get some output, the translator is translate our program into machine code. Very good. After the computer start to execute the machine code, it gives us the output. Yes, that's what I'm expecting. See, CPU understand the programming language and the compiler convert the machine language. Okay, so now you are on the track. Okay, so you have understood how the computer program is working. Okay, so first of all, you have to understand whatever the program that you are writing, it is executed by the CPU. CPU is the person who is responsible for executing your program. So execution in the sense giving you the output, giving you the result. But here, one thing you have to keep in mind, CPU, it's the processing unit of the computer, like it is the main part of the computer. So here, one thing you have to understand, it cannot understand whatever the language you are using, whatever the programming language that you are using to write your program. So rather, CPU can understand only the machine language. Okay, it can understand only the machine code or the machine language. So what happens? Your source code is converted into the machine code. So in order to make your program work, what happens? Your source code, the program, whatever the program that you are writing, we are calling that as a source program or as a source code that is converted. So here you can see an example. Okay, so this is the source code and that source code is converted into a machine code. Then the program will be able to execute it by the CPU. So now we will see the continuation. Programmers write the code in the high-level language such as C Sharp, Java, Visual Basic, etc. So I told you, right? Now we are not going to write the program in a machine language or in an assembly language. Of course, we are going to write the program in a what we call in a high level language. Okay, so we can use whatever the language. So assume that in our scenario, we are going to write the program using Java. Okay, so then using a software tool, this high level code is converted into a machine code. Okay, so there is a conversion. High level code is converted into a machine code. Then the software tool that does the conversion to machine code comes in two flavors. Yeah, so that you have to know. Okay, so here there is one point, right? So what happens? Whatever the programmers are writing using the high level language should be converted into a machine code so that the program is executed. Okay, so how it does, that comes in two flavors as compilers and interpreters. So any idea on what do we mean by these compilers or what do we mean by these interpreters? So if you have any idea, you can let me know. Tell me what do you mean by compiler and what do you mean by interpreter? So what happens? The software. So here you are going to actually convert your high level language. The program that you are writing using a high level language. So in our scenario, you can take Java into actually we are going to a software tool. So that software tool can be a compiler or an interpreter that can convert the high level language into a machine language or into a machine code. Okay, so tell me about like any idea on what is this compiler and what is this interpreter? So there is an answer. Both are translators. They are a little bit different between both. Okay, good. So you know to some extent. Very good. So here, compiler. A compiler converts your entire program to machine language or machine code at one time, at one go. After compilation, you have an executable file in the machine code. Okay, interpreter, what it does, an interpreter converts your program into machine code, one instruction at a time. Okay, so this is how it works. So you can our task is to change your source code into machine code. So in between the source code and machine code, you are having an intermediator. In between them, there is a middle party who is actually involved in doing that task. So that middleman we are calling as, so that can be of two types. It can be a compiler or it can be an interpreter. So compiler means what it does, it converts the entire program into machine code at one single time. So once you have completed writing the whole program and once you are saving it and when you compile it, the whole program will be converted into a executable file, a compiled file. Okay, interpreter, what it does like most of the time we tell that but one instruction at a time. So one by one. Okay, so these two types of software tools, so these two types of middlemen are possible or they are available to convert your source program or your into uh, source code into what we call the machine code. Okay, so now I will move to the next one. compiling the source code. Okay, compiling. A program written in a so compiling means now you should know. When you hear the term, you should know what kind of mechanism is taking place there. Can you tell me? So what happens at the like when it comes to compiling? What happens? So there are plenty of replies. Yeah, the entire program is converted into machine code in a single tap. That's the idea. So you know. Okay. So some compiling source code. A program written in a high-level language is called a source program. Since a computer cannot understand a source program, a program called a compiler is used to translate the source program into a machine language program called an object program. The object program is often then linked with a supporting library called supporting library before the object can be executed on the machine program. So this is some kind of a advanced thing on how the things are actually taking place. So now you know the high level picture, the big picture. So there is a source code, there is a machine code. Source code is getting converted into machine code. So at the conversion, at the middle point, as the middleman, you will be having a compiler or an interpreter. But in detail, this is how it takes place. So there will be a source file, then using a compiler, it is converted into a machine language file, and to execute the machine language file, you need some other things like some important or the libraries, some important libraries. So here you have the library code, and also there is a linker, and finally you are getting the executable file. So this is the detailed idea on how the compilation of the source code actually takes place. So is it all understood and clear? Before I move to the next part, is that all understood and clear? Okay. So developing programs that run on multiple platforms. Okay. Okay. So this is what now the need of today's world is. Okay. So now assume that you are writing a program. You are writing a program in Java, and you are going to execute in your program in a Windows supported machine. Okay, on a Windows supported machine. But when it comes to the real industry settings, that is not the case. Okay, so maybe your team or like whatever the task that you are given, maybe you have done it using a Windows supported machine. But the testing team, let's say, okay, whom we are calling as QAs. So what they are going to do is they might be using an iOS platform, and your client might be running the program on a Linux environment. Okay, so the same program, what happens? You are developing it on a Windows platform, on a window on top of a Windows environment. But the testing or the people who are supposed to perform the program testing, they are going to use some other platform, some other environment, and your client is going to be on another platform, another environment. Okay, so this particular problem So here, the compatibility. Okay, so what your program should do? It should be compatible enough to get run, to get executed on all these multiple platforms, on all these three different platforms. So now we are going to look into like how that is possible. Okay, so developing programs that run on multiple platforms. You need you need to find a language that is supported by different platforms. That is the first one. Okay, so first of all, your language, whatever the language that you are going to use to write the source code, to write the program, to write the software, that should be supported by different platforms. Okay, and then what happens? Your program will be able to, or you will be able to get it executed across all these various platforms that I told you. Okay, so nowadays this is the problem, and this is the concern that the industries are very much focused on. That idea you should have in mind. Okay, so you can't always say that you can't always ask your client, okay, so use only Windows. No, that's not possible. Maybe you are using Linux and your client might be using Windows. So here, what you should do, you should always select a language that is supported by different platforms, and Java is one of them. So now we are going to see how Java is working. Okay, so initially it creates machine code for general virtual computer, which we are calling as Java bytecode. Okay, and then there are Java interpreters that are available for almost all types of computer platforms. I told you, right? So like whatever the language that you are selecting, it should be supported by multiple platforms. So Java is one of that, and Java is having Java interpreters. Uh, these interpreters are available for almost all types of computer platforms. And the next one, to run your Java program, you need the Java interpreter installed in your computer. It would convert the Java bytecode to a specific Java machine code for your computer. Okay, the same thing. Now you should be able to recall the big picture. We are going to write the source code, and there are interpreters. Using interpreters, we are going to convert them into machine code. Okay, that's how. So here you can see how Java is working. Okay, so you have the Java code, and then you have Java C compiler. It creates the class file for you, which we are calling as a bytecode. And you have Java virtual machine, Java interpreters that support different platforms. So JVM for Windows, JVM. So JVM in the sense Java virtual machine. So that's the name we are giving for Java interpreter. So Java JVM for Linux, JVM for Mac. And using them, you will be able to execute the program. So here is the detailed picture of how that is supposed to be. First of all, in the text editor, you will be writing the Java statement. Okay, and what we normally do, whatever the program that we are writing, we will be giving a name to it. So in case of Java, we will be saving the file using the name of the main class dot Java. That extension we will be using. Okay, and then you using Java C compiler, Java compiler, you will be able to create the class file. And finally, using JVM, Java virtual machine, you will be able to get the program executed. So So here is a simple Java program. Okay, so before I move into this, up to this part, have you all understood? Is everything clear and understandable? Is everything clear and understandable? Okay, very good. So now we are going to move into the important part. So how you are supposed to write a simple Java program. Okay. So now we actually we are going to work with getting into the practical content. So for that, you all have to install what we call as JDK. So what is that? You all have to, so since the language that we are going to use is Java, we have to install Java on our PC. Okay? So for that, you have to install JDK. So tell me how many of you have visited VLE to check all these things. Tell me. So sir has uploaded all the content to VLE. Logging into your VLE. This is the subject, fundamentals of programming. And here under the chapter 1, okay, you are having course guide that you can refer. And under this part, introduction to programming and JDK. So here you have the thing. Okay, so chapter 1 we have completed and we have left sheet 1. So under left sheet 1, you are having left sheet 1, you are having installation of JDK, installing Java to your PC. So have you all done this one? Or like what is your progress regarding this? One message I can see you have already downloaded JDK 21. Okay, so have you installed based on the document shared? Have you all installed? Can you please tell me? Okay, very good. Already some of you have installed, but no problem. Now we are approaching the time to conclude our class for today. Tomorrow we have 2 hours class starting at 8:30 a.m. tomorrow morning. So there I will be demonstrating you on how to download and install the JDK, and we can start with our first left sheet. That means we can start doing the program. Okay. So one thing you have to do, everyone. So it's good and much appreciated for the students who have already installed. No problem. But others, you should be able to. What you have to go do, you have to go to this link. You have to go to this link and get JDK downloaded. Okay. Please get JDK downloaded, and I think it might take some time. So get it downloaded and get it prepared. So once your execution, I mean, but once your setup file is downloaded, then we will be able to run the file, we will be able to install. We will be able to install the software. Okay, so it's a compulsory task for everyone apart from the students who have already installed. Okay, so very good and much appreciation for those students. Apart from them, others, everyone has to keep your JDK downloaded, and tomorrow I will demonstrate you how to install it, and we can do our very first program. Is that clear? Is that clear and understandable what I am telling? Okay, very good. So if so, so from here onwards, I would like to wind up our class for today, and we can meet tomorrow morning.